In this video, we will review the concepts of how to perform hypothesis testing using the p-value approach. The first thing we want to do is to determine what our parameter is. The parameter is whether your problem is a mean problem or a proportion problem. And here are the keywords or phrases that you want to look for in order to distinguish between the two. If your parameter is mean or mu, then the problem would say something about mean, average, sample mean, sample standard deviation. They would use the symbols S, X bar, or the question that they would ask their sample is a quantitative one. So they would ask a question and your response would be a number. If your parameter is proportion or P, then the problem would say something about proportion, or they would give a number out of another number. So 75 out of a sample of 130 people said blah. Or they would say, give you a percentage. 15% of people believe blah. Or this is a question that they ask where you have two mutually exclusive answers. So you give a yes or a no, or agree, don't agree, or you fall into one of two categories and there is no overlapping in those categories. So in order to identify that, you need to make sure to slow down and read the problem carefully so that you can pick out the key parts that you need. Next, you need to determine whether you have one sample or two. One sample means that there is one group of individuals that you are studying. Two samples means there are two groups that you're studying and you're comparing these groups to each other. So two samples, you're looking for male and females, or before 1970 and after 1970, or you're looking at freshmen versus seniors. So you're comparing two totally separate groups to each other. For one sample, you have one group of people and you're trying to talk about that one group of people and compare to something that's already happened in the past. Third, we need to check our assumptions. So in order to perform this type of hypothesis testing, there are some things that have to be in place for us to be able to do that. And your assumptions are based upon, number one, do you have a mean problem or proportion problem? And number two, do you have one sample or two? So in this chart, I've given you all of the assumptions that you have. There are three different assumptions, and we verify them different ways depending upon the previous information. So all of the data has to be collected in a certain way, regardless of what type of problem that you have. So either in the problem, it's going to physically state that your data has been selected by a simple random sample, or you have to assume that your data has been selected by a simple random sample or a randomized experiment. If you have two samples, then this must be true for both of your samples. If you're comparing men and women, the men must have been selected by a simple random sample, and the women must have been selected by a simple random sample as well. Next, we want to check for normality. Is the shape of your distribution approximately normal? This is called parametric testing. There are lots of other methods that you use if your data is not bell-shaped or if it's not close to bell-shaped, but that's going to be in a second or third level statistics class. Our focus is only on normal distributions. The way you check for normality, once again, depends upon, is this a mean problem or is this a proportion problem? If it's a mean problem, you have three different ways that you can check, but only one has to work. If one of these works, then you say your distribution is normal. So even in the problem, either in the problem it's going to specifically state that the population is normal. If that's true, you don't need to check anything else. It doesn't matter. Or if they say nothing about the shape of the population, then you go on to B. Is your sample size big enough? If your sample size is greater than or equal to 30, that's enough evidence for us to say that our shape of our distribution is approximately normal. If you don't have a big enough sample size, they say nothing about your population, then what you need to do is to create a normal probability plot. and create a box plot and make sure that you don't have any outliers. One of those three things has to be true in order for you to say that the shape of your distribution is approximately normal. These only work for mean problems. If it's a two sample mean problem, then you have to have one of these three for both sets of your data, for men and for women. If you're working with a proportion problem, the way you check for normality, n times p sub 0 times 1 minus p sub 0. Yes, this formula is a little different than the one you saw in chapter 9 and in chapter 6, but you still approach it the same way. P sub 0 is just the null hypothesis proportion. So whatever value you use for the null hypothesis, that's what our P sub 0 is. So you multiply these three terms together, and this value, if it's greater than or equal to 10, then we say that our distribution is approximately normal. If you have a two sample proportion, so you're looking at smoking rates in 1970 and then 1990, then you want to check and make sure your data from 1970, that's approximately normal. So do n times p sub 0 times 1 minus p sub 0 on that. And then you also take the sample from 1990 and do n times p sub 0 times 1 minus p sub 0 on that as well. Third assumption is independence. When you're selecting these samples, it is likely that people are going to end up in multiple samples. So you want to make sure that your sample size, lowercase n, is no more than, is less than or equal to 5% of capital N, your population size. What this says is that your sample size must be fairly small in comparison to the population size. If you have two samples, that must be true for both sets of data, and the data sets have to be independent of one another as well. So men, women, no in between, have to be independent of each other also. Once we have identified our parameter and we know whether we have one sample or two, and we've checked to make sure that we can actually do hypothesis testing, then we move on to step number 4, identifying what type tail test that you have. Left tail test. For your alternative hypothesis, you're going to be using less than. Your keywords that you're looking for in the problem: less than, decreased, smaller than. What a left tail test tells you is that alpha is going to be on the left hand side of your graph, and alpha is your level of significance. It's also the probability of making a type 1 error. This is the region that we're saying, okay, this is what I'm giving myself the opportunity to be incorrect. If it's a right tail test, the symbol that you're going to be using is greater than. The keywords you're looking for: greater than, increased, larger than, more than. Alpha is going to be on the right hand side. Two tail test, the symbol that you're using is not equal to. And two tail test, alpha is split over both of these ends. The keywords that you're looking for in the problem: difference, differs, changed. With two samples in chapter 11, you need to be very careful about looking at time. Be very careful about time problems. Write out your null and alternative hypothesis. Your null hypothesis is H sub 0. This is a statement of no difference, status quo, what's already been published, there's no change. What was previously known to be true, that's what you accept as your null hypothesis. That's what you write down initially. Your alternative hypothesis, your symbols are H sub 1 or HA, depending on your textbook. And this is the statement that you truly believe. This is what you're trying to find proof of. The numbers are going to stay the same in your null and your alternative hypothesis. The only thing that changes is the symbol that you use in between. So a note on two samples, you could see your null hypothesis written like this: mu sub 1 is equal to mu sub 2, p sub 1 is equal to p sub 2. The other way that you might see this is they might put everything on one side, meaning they'll solve and set it to 0. So you would have mu sub 1 and moving mu sub 2 to the other side minus mu sub 2, that equals 0. And our two sample proportion, p sub 1 minus p sub 2 is equal to 0 for your null hypothesis. And then your alternative hypothesis, you're just changing what this sign is on the alternative hypothesis. And here I just show you another example. And once again, caution you against time problems. Make sure you pay attention if you're talking about time problems. Step number 6 is to pick your hypothesis testing method. So I have another video for you on how to perform the classical approach. This video is about the p-value approach. There's also a confidence interval approach, and that video is going to be coming up next. So once you pick your method of testing, then you move on to interpreting your results. What does that mean? So from one of these three methods, you're going to do one of two things. You're either going to reject the null hypothesis, you're going to reject the status quo, get rid of what's already been published in the newspapers, or you're going to fail to reject it. You're not going to reject it. So you're either going to say, I have enough evidence, you're wrong, you don't know what you're talking about, or I don't have enough evidence, so you might be right, maybe. I just don't have enough proof to say otherwise. So you're either going to reject the null hypothesis, the status quo, or you're not going to reject it. Then, if you reject the null hypothesis, you reject the status quo, you tell that other person they're wrong, you have to explain why. So it's because you have sufficient evidence of the alternative hypothesis. You have enough proof of what you believed have happened. How you remember this? Your mnemonic device, your alphabet, you have R and then you have S. So if you reject the null hypothesis, it's because you have sufficient evidence of the alternative. It's always twofold. Reject the null because you have enough evidence of the alternative. Or you don't reject the null because you don't have enough evidence of the alternative. So negative Nancy is your mnemonic device here. For not rejecting the null, everything has a negative connotation to it. And these three at the bottom are three things or three ways of saying the same exact thing. So if you fail to reject the null, you can say there's insufficient evidence of the alternative. Or you could say there's not enough evidence of the alternative. Or you could say there's statistically insignificant evidence of the alternative. Three different ways of saying the same exact thing. Now let's get into the p-value approach. So your p-value is a probability, and it's the probability of getting your sample or a sample more extreme than yours, assuming that the null hypothesis is true. Assuming that the null hypothesis is true. So the whole process of hypothesis testing, somebody makes a claim about the population, we don't agree with it, we go out and collect our own sample, and we're trying to use our sample as evidence against the status quo, what's already been published. So we find the probability of getting our sample, assuming that the null hypothesis is true, assuming that the mean that is stated is the mean, or the proportion that is stated is the proportion. And we calculate the probability of that. So previously we did that with normal CDF, if you're in the calculator, or stat calculators in normal, if you're in StatCrunch. Now we have functions in our calculator that will take care of this for us. So to find your p-value with the calculator, you're going under Stat and then Tests. So if you want to find the p-value in a mean problem, you're going to be going under t-test. If it's one sample and a mean problem, you're going to t-test. Z-test we never use in this course. Z-test is if you know the population standard deviation, if you know what sigma is. In our course, we never know what sigma is, so we never use this function. So we're only using t-test. T-test, we know the sample standard deviation only. If you have two samples, we're using two-samp t-test. We don't know the population standard deviation. We don't know sigma. All we know is S, the sample standard deviation. That's why we're using the student's t distribution and everything has a t in it. If this is a proportion problem and you want to find your p-value, if you have one sample, you're going to one prop z test, one sample. If you have two samples, you're going to two prop z test. Your output differs, but what's always going to be the same is that this line with the p is your p-value. The probability of getting your sample or a sample more extreme than yours, assuming that what was given in the null hypothesis is true. If you're a stat crunch person, mean problems you're going under stat and t-stats, proportion problems you're going under stat and proportion stats. And the very last part of your output is your p-value. So what we do with this probability is we compare it to alpha. So if our p-value is smaller than alpha, our level of significance, our probability of making a type 1 error, if the probability of getting our sample is much smaller than our alpha value, typically 5%, 0.05, 10%, 0.10, or 1%, 0.01, then we reject the null hypothesis. And when you reject the null, that's because you have sufficient evidence. Hope this video helps. Coming up next, we have confidence interval approach.